In this video, we're going to learn how to add and subtract square roots. Like radical terms are like terms that have the same index and radicand. So if you have a square root, let's say that, or actually let's talk about a cube root to make it clear. So if I have the cube root of 8, in this example, this 3 is called the index. If you have a square root, you don't see an index because it's automatically assumed to be a 2. And then the number inside the radical, so in this case 8, that is called the radicand. So that's the number inside the radical symbol. So to have like radical terms means that we have to have square roots that have the same number underneath the square root symbol. And that will give us like terms. So are the following pairs like terms? Circle yes or no, and then explain your answer. So don't just circle yes or no, you gotta write an explanation. That's how they're gonna ask you on the milestone. So we wanna make sure that you know how to do all that. So 2 square roots of 5 and 5 square roots of 2. Are these like terms? So what we wanna look at is the square roots. Do they have the same number underneath the square root symbol? No. So these are not like terms because they have different radicands. And again, a radicand is a number underneath the square root symbol. For example 2, we have the square root of 7 and 4 square roots of 7. So again, we're looking at that square root symbol. Do these have the same number underneath the square root symbol? Yeah, they're both the square root of 7. They don't have the same coefficient, but that is okay. So yes, they have the same index, meaning that they are both square roots, and radicand. And again, the radicand is a number inside the square root symbol. Excuse me. For example 3, I have 10 square roots of 3 and negative 2 square roots of 3. So these both have the square root of 3. So these are like terms. It's okay that they have different coefficients as long as they have the same square root and the number inside. So yes, they have the same index and radicand. Example 4. Here I have 10 square roots of 5 and 10 square root of 3. Are these like terms? No, because they have different radicands. This one's radicand is 5, while this one's radicand is 3. When we have like terms, meaning the same number underneath the square root symbol, we can simplify expressions. So on example 5, we want to add 3 square roots of 5 and 4 square roots of 5. These are like terms because they both have the square root of 5. When this happens, we can add the coefficients. 3 plus 4 is 7. So my answer would be 7 square roots of 5. Think about this like how you did with polynomials. If I had 3x plus 5x, these are like terms because they both have an x. So now all I have to do is add my coefficients. 3 plus 5 is 8x. So you're going to think about these radicals the same way that you would polynomials. Sometimes we need to simplify the radicand before adding or subtracting. So if I look at example 6, I have the square root of 2 minus the square root of 8. These are not like terms because this one has a radicand of 2 and this one has a radicand of 8. When you do not have like terms, you want to do the birthday cake method first. So let me try to simplify this. So if I do birthday cake for 2, the smallest prime number that goes into 2 is 2. It goes in 1 time. When you get to 1, you're done. That's the candle to your cake. I don't have any pairs here. So that means that the square root of 2 is as simplified as it's going to get. Now I need to simplify the square root of 8. The smallest prime number that goes into 8 is 2. 2 goes into 8 4 times. The smallest prime number that goes into 4 is 2. 2 goes into 4 2 times. The smallest prime number that goes into 2 is 2. 2 goes into itself once. When you get to 1, you're done. That's the candle to your cake. I am looking for pairs of numbers to leave the square root symbol. Here I have a pair of 2's that can leave. This 2 does not have a pair, so that 2 is going to stay inside the square root symbol. Now I have like terms because these are both the square root of 2. So because they are like terms, I can subtract my coefficients. I know I'm subtracting because that is the sign I have here. So the coefficient of the square root of 2, when there's not a number there, it's a 1. So 1 minus 2 is negative 1. So my answer is negative 1 square root of 2. You could also write this as the negative square root of 2. Both of these represent the same number. Let's go ahead and try example 7 and example 8. On example 7, I have like radical terms because they are both the square root of 2. So I can go ahead and add my coefficients. 3 plus 9 is 12. So my answer would be 12 square root of 2. On example 8, I do not have like terms because this one is the square root of 10 while this one is the square root of 40. So I'm going to need to do birthday cake first. I'm going to begin by bringing down my coefficient of 2. That way I do not forget about it. And then I'm going to do birthday cake for 10. The smallest prime number that goes into 10 is 2. 2 goes into 10 5 times. The smallest prime number that goes into 5 is 5. 5 goes into itself 1 time. When you get to 1, you're done. 1 is the candle to your cake. I'm looking for pairs of numbers to leave the square root symbol. And I don't have any pairs. So that means that the square root of 10 is already as simplified as it's going to get. Now I'm going to do the same thing with the next one. I'm going to bring down my negative 7, and I'm going to do birthday cake for 40. The smallest prime number that goes into 40 is 2. 2 goes into 40 20 times. The smallest prime number that goes into 20 is 2. 2 goes into 20 10 times. The smallest prime number that goes into 10 is 2. 2 goes into 10 5 times. And then the smallest prime number that goes into 5 is 5. 5 goes into itself 1 time. When you get to 1, you're done. That is the candle to your cake. I am looking for pairs of numbers to leave the square root symbol. Here I have a pair of 2's that can leave. Those 2's are going to get multiplied by the 7 that was already out in front. This 2 and this 5 do not have a pair, so they are going to stay inside of the square root symbol. when you have more than one thing staying inside of the square root symbol, you multiply them together. So right now I'm going to bring down my 2 square roots of 10. And then negative 7 times 2 is negative 14. And 2 times 5 is 10. Now I have like terms because they are both the square root of 10. 2 minus 14 is negative 12. So my answer is negative 12 square root of 10.